Section 2.3, angles formed by transversals. A transversal is a line that intersects two or more coplanar lines at different points. So, let's take a look at this. This line that I'm highlighting red is intersecting two other lines. So that's what we call a transversal. It doesn't always go up and down, it could go any direction. In this diagram down here, this is my transversal line. Why is it a transversal? Because it is intersecting two other lines at different points. Now, it's important in these diagrams, I would label the transversal a little lowercase t. And then I'd identify certain regions that are formed here. In between the two lines, I'm going to highlight in here. This is what we refer to as the interior, which I'm usually going to abbreviate INT for interior. And then outside of the two lines that I'm highlighting here and here, we refer to those regions as the exterior. So it's very important that you're able to identify where's the interior and where's the exterior. Okay, so again, here in this diagram, the exterior is not up and down, it's the left and right. It's outside of the two lines. So that would be the exterior region here. And once again, the interior is in between the two lines that the transversal is crossing. So this would be the interior. Now, previously we learned about vertical angles and linear pairs. At this intersection here, I've got vertical angles and linear pairs. At this intersection down here, I also have vertical angles and linear pairs. However, how do these angles up here relate to these angles down here? Because vertical angles and linear pair only occur at one intersection. But are there special angle pairs formed at these two different intersections? There are, and that's what we're going to talk about this lesson. The first is called corresponding angles. They're in the same position relative to the intersection of their line and the transversal. If two angles are corresponding, one must be located in the interior and one must be located in the exterior. They're never adjacent or next to each other, located at the same intersection. So what am I talking about? Here's my transversal line. Now, all these new angle pairs that we're about to learn, one must come from the intersection at the top and one must come from the intersection at the bottom. So once again, this is my interior and this is my exterior. And I'm going to circle each intersection. I have an intersection there and I have an intersection here. So all these new angle pairs that we're learning about, one must come from up here and one must come from down here. So what makes angles corresponding? You can think of those as maybe dinner tables. They're angles that are sitting at the same seat at each dinner table. So what am I talking about? Look at angle 1. Here's the intersection that I'm going to put a blue dot on. How would you get to that angle? That angle is up and to the left of that intersection. Well, if I'm at this intersection here, what is up and left? Angle 5. Angle 1 and angle 5 are in the same position, so they are corresponding angles. Something weird happened in the formatting when I exported this. So I'm just going to go ahead and fix this really quick. I'm just going to do that. All right. So what about angle 2? Angle 2 is up and to the right. What is up and to the right at the other intersection? 6. So angle 2 and angle 6 are corresponding angles. All right, what about angle 3? Angle 3 is down and to the left. What is down and to the left down here? Angle 7. So angle 3 and angle 7 are corresponding. And then last, my last pair of corresponding angles. Down and to the right, we have angle 4. Down and to the right is angle 8. Now we're going to see that all these special angle pairs have certain relationships in certain situations in another section. So the main goal of this section is to be able to identify, 4 and 8 are corresponding, because that's going to be part 1 of other things we're doing with these. So Identifying them is important. Next is alternate interior angles. Okay, well, what are alternate interior angles? Well, once again, we want to focus on where's our transversal, where's the interior, where's the exterior. So again, my transversal is this line here. Alternate interior angles are located in the interior, which means we can automatically ignore 1, 2, 7, and 8. They're on opposite sides of the transversal. They're in the interior, but they're not next to each other. They're not at the same intersection. So the alternate interior angles would be angle 3. That's on the left of the transversal. What's on the right of the transversal, but not next to it, not attached, that would be angle 6. Angle 3 and angle 6 are alternate interior. So are angles 5 and angle 4. So that's 3 and 6. And 4 and 5. Again, had a weird little format error, so I'm just going to do that. What about alternate exterior? Well, if alternate interior, let me just copy this real quick. Oop, that did not work. Let's see. There we go. Might have been quicker at this point to actually just draw it again. There we go. If alternate interior were on opposite sides of the transversal and on the inside, well, that means alternate exterior are going to be the same thing, but on the outside, not on the inside. So angle 1 is on the exterior and to the left of the transversal. Angle 8 is in the exterior and on the right-hand side. Now remember, it's not 1 and 2. Angle 1 and 2 are a linear pair. It's always 1 from the intersection up here and 1 from the intersection down here. The other alternate exterior angles, well, look, we've got angle 2 that's in the exterior. That's on the right-hand side. And on the left-hand side down here would be 7. So angle 2 and 7 are alternate exterior angles. The last would be same side interior angles. They're also called consecutive interior angles. Now, they are also located in the interior, and they're on the same side of the transversal. So angle 3 is on the left. What else is on the left in the interior? Angle 5. So angle 3 and angle 5 are same side interior angles. What about on the right-hand side? We have angles 4 and angle 6, which would be the same side interior angles there. Use the diagram to identify all the pairs of angles of the given type. Well, first of all, let's identify where's my transversal line. Oh, this is it that I highlighted red. Inside the two lines is the interior, and outside is the exterior. All right, here we go. Corresponding angles are in the same position. So angle 1 and angle 5 are corresponding. They're up and to the left, up and to the left. 3 and 7 are also corresponding. Up and to the right, up and to the right. What about angles 2 and 6? Down and to the left, down to the left, same position. They are corresponding. And last would be 4 and 8. Alternate interior. Well, now we want to focus on the interior and only choose between 3, 4, 5, and 6. Alternate would be on different sides of the transversal. 3 is above the transversal. What's below the transversal but not next to it in the interior? 6. 3 and 6 are alternate interior. What about angle 4? That's also in the interior. That is in the interior and below the transversal. And then above it, the other intersection would be angle 5. Alternate exterior, same concept, but we're looking on the outside. Angle 1 and 8. And angles 2 and 7. Consecutive interior, which is also same side interior, would be angles 3 and 5. They're both above the transversal. and 4 and 6. Now, what I would like you to do is pause the video, and I want you to go through and identify all the remaining angle pairs in examples 2 or 3. In angle 2, what I want you to do is just focus on classifying them as the new angles. Are they corresponding, alternate interior, exterior, or consecutive interior? Whereas angle 3, if they're none of the new angles, figure out maybe they're different types of angles that we've learned about. Maybe they're vertical angles or linear pair, or maybe they're none of the above. So try them out, pause the video. When you're done, unpause the video and check your answers. Example 2. Well, here's my transversal. This is up and to the right. This is up and to the right. Same position. Those are corresponding angles. Here's my transversal. 1 and 2 are both in the interior, and on different sides of the transversal, those are alternate interior, I'm abbreviating, angles. Alternate interior angles. 5 and 6, here's my transversal. They're both located in the interior. Now, reminder, it might be helpful if you do this on all the diagrams. You don't have to. But they're in the interior, and they're both on the top. They're both above the transversal. They're on the same side of the transversal. So those are same side interior angles. Next, these are alternate exterior angles. Again, here's my transversal. They're in the exterior and on different sides of the transversal. 3 and 4. Well, once again, those are same side interior angles. Why? Here's my transversal. This region is the interior that I'm highlighting yellow, and they're both on the right-hand side of that transversal. Next, here is my transversal line. This is the bottom left corner. This is the bottom left corner. They're in the same position. Same position is corresponding angles. Here's my transversal. Here's my interior. 1 and 2 are in the exterior. 1 is to the left, 2 is to the right. Those are alternate exterior angles. In this diagram, here's my transversal. 7 and 8 are located in the interior and on different sides of the transversal. Those are alternate interior angles. 3 and 4. Well, let's take a look at 3 and 4. They're both located at the same intersection, which means they can't be corresponding alternate, or consecutive, or same side interior, because those are located at different intersections. Well, 3 and 4 are next to each other, and look at this. 3 and 4 are next to each other, forming a straight line. That is a linear pair. 5 and 8 are at the same intersection, so they're not any of the new angles we were discussing in this section. Maybe they're, vertical angles. What about 1 and 2? Again, none of the new angles because they're located at one intersection, and they're next to each other, forming a straight line. That is a linear pair again. Now, 7 and 8 are not a linear pair. They're not vertical angles because they're located at different intersections. 7's in the exterior. 8 is in the interior. So they're not alternate exterior. They're not alternate interior. They're not same side interior. Are they corresponding? No. 7 is up and to the left. 8 is up and to the right. So that is quite literally none. That is none of the special angle pairs we've learned about. 5 and 6, once again, vertical angles. 1 and 2. Here's my transversal. This that I'm shading yellow is the interior, while they're in the exterior and on different sides of the transversal. That makes them alternate exterior angles. Here's my transversal. Up and to the left, up and to the left. They're in the same position. That makes them corresponding angles. Here's my transversal. This is down and to the right. That's down and to the left. They're not corresponding. They're not alternate interior because 3 is not on the inside. They're not alternate exterior because 4 is not on the outside. They're not same side interior. They're also not vertical angles. They're not connected. And they're not linear pair. They're not forming straight lines. So this is none of the above.